I stand from the University of British Columbia, Okanagan, presents Mathapults Part B. First, let's look at the important parts of a catapult. The arm supports the load. The fulcrum is what the arm turns on. It is known as the pivoting point. The base stabilizes the catapult structure. Here you can see the arm and the base together make an angle. Do you know what type of angle this is? The catapult was in a position that formed an acute angle. An acute angle is sharp, like the end of a pencil. The unit of measure for an angle is degrees. The symbol in the middle shows that an acute angle is less than 90 degrees. Just think of the less than symbol like an alligator mouth. The alligator always wants to gobble up the bigger number. What do you think a 90-degree angle looks like? A 90-degree angle is called a right angle. A right angle makes the corner of a box. A right angle is always equal to 90 degrees. What angle is greater than 90 degrees? An obtuse angle. Think of an obtuse angle as the corner of an octagon. The symbol in the middle shows that an obtuse angle is greater than 90 degrees. Remember, think of the symbol like an alligator mouth. It always wants to gobble up the larger number. Can you remember all the types of angles? An acute angle is less than 90 degrees. A right angle is equal to 90 degrees. And an obtuse angle is greater than 90 degrees. The projectile, or load, is what we fire. Sharp objects, objects with hard corners, or heavy objects like a marble are not safe to fire. For your projectile, try to use objects like a pom-pom, Play-Doh, or a rubber ball. Check your knowledge. Can you identify where the fulcrum is on the catapult that we built? The fulcrum is the clip. Now make sure you have your I Stand Mathapult Part B worksheet ready. We are going to use the scientific method to learn all about our catapult. The scientific method is used to conduct research. Let's follow the steps. First, we need to make observations. Let's watch what happens when we fire our catapult. What did you see happen? Let's fire our catapult one more time. Now draw or write down what you saw on your Mathapult worksheet. Pause the video if you need more time to draw. Did your projectile travel like this? Do you know what the shape of this curve is called? Is it concave or convex? It's concave. Concave shapes curve inward. To remember the word concave, just think about how a cave goes inward. What do you think the shape of a convex curve is? Here you can see it's the opposite of concave. Convex shapes curve outward. Can you identify if these objects are concave or convex? A football curves outward, so it is convex. The vase curves inward, so it is concave. The umbrella is both concave and convex. The outside of the umbrella curves outward, and the inside of the umbrella curves inward. It's time to form a hypothesis. Let's make a prediction. Will a heavier object or a lighter object be catapulted further away? Write down what you think will happen on your Mathapult worksheet. Pause the video if you need more time. Now let's conduct the experiment. For the lighter object, try to use something like a pom-pom, and for the heavier object, try to use something like Play-Doh. Now fire your catapult. Make sure you record your results on the Mathapult worksheet. Measure the distance between the base of your catapult and where your projectile landed. DI, or your initial distance, will be 0 because that's where your projectile started. Use your measuring tape to find the final distance, which is where your projectile landed. Record the results in your table on your Mathapult worksheet. Fire your catapult twice with the pom-pom and twice with the Play-Doh to see which will go further. If you have a timer handy, you can also time how long your projectile is in the air for. Do you know where the median is? The median is in the middle. Find the halfway distance on your measuring tape and record it in your table. Or you can divide your final distance by 2 to find the median. Do you notice anything else about the median? In this case, it is the distance at which our projectile was at its highest point in the air. The final step of the scientific method is the conclusion. Which went further, your heavier object or your lighter object? Write down what happened on your Mathapult worksheet. We looked at how heavy our projectile objects were. Can you think of anything else that might have affected the results? What about air resistance? Air resistance slows objects down that fly through the air. Depending on the surface of your projectile, air resistance can affect objects differently. Other forces can also affect your projectile. Can you think of anything else that might have affected the trajectory of our projectiles? What would happen if you made some modifications to your catapult? What if you increased the length of your arm? What modifications can you make? Go ahead, explore the possibilities. Thank you for joining I Stand Mathapults Part B.